So in the question number 5th, we have to show that for any positive number n, nth power of 1 plus I plus nth power of 1 minus I equals to 2 into 2 raised to n by 2 into cos of n pi by 4. सो इस क्वेश्चन को अगर आप ऑब्जर्व करेंगे, अगेन यहाँ पे किसी कॉम्प्लेक्स नंबर के nth पावर में ऐड किया गया है उसके कॉम्प्लेक्स कॉन्जुगेट का nth पावर, ओके। एंड सेकंड ऑब्जर्वेशन यहाँ पे क्या है कि जो राइट हैंड साइड है वहां पे मुझे आंसर कॉस के टर्म में चाहिए, यानी कि आई हैव टू कन्वर्ट दिस पर्टिकुलर कार्टेशियन फॉर्म इनटू इट्स करस्पॉन्डिंग पोलर फॉर्म, ओके। सो लेट्स कन्वर्ट 1 plus I into its polar form. So let R is modulus and theta is amplitude of 1 plus I, okay. So if I compare 1 plus I with A plus IB, then I will get A equals to 1 and B equals to 1. So this implies that theta will belongs to first quadrant because A is greater than 0 and B is also greater than 0. So if A and B both are greater than 0, then theta will belongs to quadrant 1. So एक्चुअली में इस पर्टिकुलर प्रॉपर्टीज को हमने पोलर फॉर्म में डिटेल्ड में देखा है, तो आप उस वीडियो को देखिए तो आपको एग्जैक्टली समझ जाएगा कैसे हम थीटा को आसानी से कैलकुलेट कर सकते हैं, ओके। सो hence we can apply the formula for theta, that is tan inverse of B by A. So this is equals to tan inverse of, now B is 1 and A is 1, so tan inverse 1 is pi by 4, okay. Also R is equals to square root of sum of square of imaginary part and real part, that is A square plus B square, which is equals to 1 square plus 1 square here, okay. So this is equals to square root of 2. Now I can write 1 plus I is equals to R, that is root 2 into cos theta, that is cos of pi by 4 plus I sin pi by 4, okay. So therefore 1 plus I raised to n will be equals to root 2 raised to n into cos of pi by 4 plus I sin pi by 4 raised to n, okay. So now I will apply De-Moivre's theorem. So according to De-Moivre's theorem, I can multiply this particular n with pi by 4. So this is equals to, now root 2 can be written as 2 raised to 1 by 2. So this whole expression can be rewritten as 2 raised to n by 2 into cos of n pi by 4 plus I sin n pi by 4. Let this is equation number 1. So since this is polar form of 1 plus I, so therefore polar form of 1 minus I can be obtained by replacing this I with minus I. So this is equals to root 2 into cos of pi by 4 minus I sin pi by 4. Hence 1 minus I raised to n is equals to root 2 into cos of pi by 4 minus I sin pi by 4 raised to n, which is equals to root, okay, here will be here it should be root 2 raised to n. So this is root 2 raised to n into cos of n pi by 4 minus I sin n pi by 4. This is by De-Moivre's theorem, okay. So let this is equation number 2. If I add 1 and 2, then I will get 1 plus I raised to n plus 1 minus I raised to n equals to, now root 2 raised to n is actually 2 raised to n by 2, so I can take 2 raised to n by 2 common from equation 1 and 2, so I can write 2 raised to n by 2 inside the bracket. Now these imaginary parts will get cancelled out and I will get twice of cos n pi by 4, okay. So this is actually the RHS of this question, okay. So let's see question number 6.